We are now on to the section 3 chunk of lesson 5-1, which covers questions 5 through 8. On the previous slide, you would have seen a little math tip about the Pythagorean theorem, which you should have gone over. Here, we're going to answer questions 5, 6, 7, and 8. 5, 6, 7, and 8. I feel like it should take us about 5 minutes or less. So we're going to go ahead and start there. If we need to extend the time, I will. But let's kind of look at what we're supposed to be doing here. Number 5 says, use the Pythagorean theorem to find PQ and show your work. Love this part. Show your work. Doesn't do any good if you just give me the answer. Number 6, attend to precision. What's the distance between points P, 1, 4, and Q, 13, 9, and how do you know? 7, how do you know that the triangle you drew in item 2 is a right triangle? And number 8, what relationship do you notice among the coordinates of points P, Q, and R? And again, 5 minutes. Go ahead, pause your video now. As you can see, the answers to section 3, questions 5 through 8, have now been provided. In question 5, I worked through the Pythagorean theorem that was given to me in the math tip. A squared plus b squared equals c squared, where a was my horizontal leg, b was my vertical leg, and c was that slanted leg or slanted hypotenuse that on the slant. Okay, and so I plugged it in accordingly. We got 12 squared plus 5 squared. Well, 12 to the second power is 144. 5 to the second power is 25. And when you add those, you get 169. Well, the square root of 169 is 13 units. Well, I said, if we know that we know that the Pythagorean theorem told us that PQ was 13 units, then that means that the distance from P to Q is also 13 units because that was the length of PQ, the line segment. Number 7 says, how do we know that the triangle that we drew back in item 2 was a right triangle? Well, one line was horizontal, the other was vertical. So that means that they're perpendicular and intersect at a right angle. If you have one right angle in a triangle, that makes it a right triangle. I kind of alluded to the answer to number 8 already. It said, what's the relationship you notice among the coordinates of points P, Q, and R? I said that the y coordinates of P and R are the same, and the x coordinates of Q and R are the same. And I drew attention to this whenever I looked back and I said, there's no reason for us to subtract the x values here because they're already the same. So I would subtract the y values. So I kind of already referred to it. I just didn't say it in the way that it's written here in question number 8. On to your debriefing question.